Hello IP Stats, this is Eric Cedarstov bringing you Chapter 7. This chapter rotates a lot around these two concepts of a parameter and a statistic. A parameter describes a characteristic of a whole population, such as the proportion of CCA students who drive to school. A statistic describes the characteristic of a sample, such as the proportion of a sample of 100 CCA students who drive to school. Characteristics of populations are also shown in distributions like the ones below. On the left we have a burger joint that sells burgers with and without cheese. The parameter here is the proportion of burgers sold without cheese in one day, in this case being about 60%. On the right we have the daily calorie intake for all NFL athletes. The parameter here is the average daily calorie intake for NFL athletes, in this case being a little less than 3,000 calories. Sampling distributions are a collection of all possible combinations of characteristics from samples of size n. For example, if all possible samples of 30 burgers sold at the burger joint in a day had their proportions of non-cheeseburgers graphed, we would have this sample distribution. However, it's not very practical to obtain, so usually we are given an estimated sampling distribution, which don't include all possible combinations. Other key concepts include biased and unbiased estimators. A statistic is an unbiased estimator when the mean of the sampling distribution of those statistics is the parameter the statistic is measuring. A biased estimator is the opposite. So for example, the mean of the sampling distribution of burgers is about 0.6, which is also the parameter of the proportion of burgers sold in a day without cheese. Therefore, because those match, the sample mean is an unbiased estimator. Finally, variability is basically how spread out the sampling distribution is. If large samples are taken, there's less variability, which is a good thing. Now we're going to go over some other key concepts surrounding population proportions and population means. The parameter of a population proportion is p, while for means it is mu. The statistic is p hat for proportions, and for means it is x bar. When talking about sampling distributions for each, the mean of the proportions is actually equal to the parameter, which is the population proportion of what you're trying to find. And the standard deviation for the sampling distribution is shown here, the square root of p times 1 minus p over n. For means, the mean of the sampling distribution is also equal to the population mean of what you're trying to find, and the standard deviation is the population standard deviation over the square root of n. Some conditions for both is to be able to find the standard deviation, 10% condition needs to be met, which means that the sample sizes need to be less than 10% of the population. To be able to consider the sampling distribution as normal, which is normal approximation, for proportions, n times p and n times 1 minus p need to be greater than 10. And for population means, if the population distribution is normal, then we can consider the sampling distribution normal. But if it isn't, we need to consult the central limit theorem, so the sample sizes need to be greater than 30. Other stuff is a distribution called the distribution of sample data. So this is just the distribution of one sample. In this case, let's say the 30 burgers are chosen, and we just see that 13 are with cheese, 17 no cheese, so we get a sample proportion of 17 out of 30, and all of the samples and all of these proportions are graphed on one distribution to get the sampling distribution. Same idea over here. If we take a sample of 30 NFL athletes, that sample mean is 3,000 calories. And if we take all possible combinations of those samples, we get the sampling distribution. Finally, I want to go over an example problem. So suppose 20% of CCA students are in or have taken a Japanese class. We want to find the probability that out of a random sample of 100 students, 20 plus or minus 3% of the students in the sample have taken or are in a Japanese class. So our P is 0.2 as our parameter proportion is 0.2 from the 20%. Our sample size is 100. And this is us stating we want to try to find the probability that our sample proportion is between 17 and 23%. So to find the mean of our sampling distribution, it's simply equal to the parameter proportion, which is 0.2. Then to find the standard deviation, we need to ensure the 10% condition. So 100 students times 10 is 1,000, which is less than the population. So that condition is met. So we can find the standard deviation using our formula. We get it as 0.04. Next, we want to ensure normal approximation can be applied. So we can use a standard normal graph to find our final probability. N times P and N times 1 minus P are 20 and 80 respectively, and they're both greater than 10, so the condition is met. We can then use z-scores to find the bounds of 17 to 23%. After doing the math, we have z-scores of plus or minus 0.75. These translate to probabilities of about 0.2266 and 0.7734, and the range between these is 0.5468. So finally, we conclude that about 55% of random samples of size n equals 100 will have 17 to 23% of the students in or having previously taken a Japanese class. Thank you.